Welcome to another video on rough cut capacity planning methods. In this video, we will look at the method known as resource profile method. Just to do a quick recap, we saw two other methods in the previous videos. The first one is the overall factors method, while the second one is the capacity bills method. Now, the resource profile method is more detailed than the previous two methods, as it considers an additional dimension of lead time. Now, what is lead time? Just in simple words, lead time is basically the time taken to finish any activity. For example, if you order food in a restaurant and it takes them 15 minutes to serve, then the lead time to serve that dish is 15 minutes. Now, let's consider bill of material and routing to understand the resource profile method. Now, this is the bill of material and routing that we will use to understand the resource profile method. Now, for ease of understanding, I've used the same example of bill of material and routing as I had used in the capacity bill method video. So again, just to go through the details. Now, part X is made up of A and B, and as this indicates, one quantity of A and one quantity of B is required to manufacture one quantity of X. Now, part Y is made up of A and C. One quantity of A is required, while two quantities of C are required to manufacture one quantity of Y. Now, this is the routing information. So you see all these parts and the products in the first column of this routing information: X, Y, A, B, C, and C. Now, in the lot size column, the lot size has been given for each part, which is the most optimal quantity for processing in each batch. The work center is the machine on which the operation will take place. Setup hours is required for the initial setup of machine to start the operation on the part. Now, the next column, setup hours per unit, is used to find out the hours taken by each unit of the part. The runtime per unit is the actual time taken for performing the operation on each unit of the part. And the total hours per unit gives the total time required for each part. So basically, the total hours per unit is nothing but the addition of the setup hours and the runtime per unit. So same thing has been done for each of these components and parts. Now, in this data, the lead time per operation is not considered. However, in the resource profiles method, lead time has to be considered. So for convenience, let's assume that each operation in the routing takes 1 week to complete. So if, let's say, a product needs to be completed by end of week 5, the assembly will take 1 week. So let me draw a time scale here of 5 weeks. So let's say this is 0, 1, 2, 3, 4, and 5. So if we need the assembly to be completed by this time, so assembly end, the assembly start has to be here. Assembly start. Because we have been given the lead time to do assembly or this operation on X or Y is, let's say, 1 week. Now what this means is that the components required to assemble those products must be built by end of week 4. So here you should have the availability of components. So let's use this concept to find out the time required per unit on each work center to make one product of X and one product of Y. So let us first consider that product X is going to be delivered at the end of week 5. So here we will have product X being delivered in week 5. Now X requires A and B. So A has to become available by end of week 4, so that product X, which has the lead time of 1 week, can be worked upon in week 5. So product A will be here, which has to be produced in week 4 on work center 200. Now X also requires B. B has to be worked upon on 300, and this also should be available by end of week 4. So we can have here product B. Now let's look at the time required for each of these operations. Product X requires 0.517 hours per unit. So this will become 0.517. Product A requires 0.72. So this will be 0.72. And product B requires 0.32. So this becomes 0.32 hours per unit. So this is how the requirement of hours per unit for each work center to make one product of X for week 5 looks like. Now let us do the same calculation for product Y. Now in week 5, the assembly operation of product Y has to be completed. So it will start and end in week 5. Now as we can see in the routing information, Y is being worked upon by work center 100 and it requires 1.125 hours per unit. So in week 5 it will be product Y Now this means that the production of components has to be completed by the end of week 4. Now the preceding activity is production of A and C, because A and C are the components required for manufacturing Y. Now for A, work center 200 is required. So let's add this in week 4. So this will be product A will be done in week 4. Now on C, 2 operations need to be performed. So this one and this one. Let's assume that this routing information has the reverse order of sequence of operations. So which means that first C has to be worked, and this is the first operation, then this is the second operation, and so on. So the second operation, that means the one which is on machine 300, needs to be done first. Now since we are going in the reverse order of the operation, we first looked at the time requirement for Y, then we looked at the time requirement for product A, then we look at the second operation of C, which has to be performed on machine 200 as well. So A and the second operation on C has to be performed on machine 200. So product A plus C, which is op 2. So in that case, the first operation has to be completed in the prior week, that is week number 3. So this one, which is being done on machine 300, has to be done in week 3. So this will be C op 1. Now let's determine the hours required for each operation. Now for product Y, the operation time required is 1.125 hours. So this is simple, 1.125. For product A, it is 0.72. And product C, that is op 2, it is 0.825. But as we were given in the bill of material, each Y requires 2 quantities of C. So the operation will have to be done for 2 components of C. So this multiplied by 2, and this will give you 2.37 hours. So this here is 2.37. And for C, which is op 1, again 0.918 multiplied by 2. So 0.918 multiplied by 2, which is equal to 1.836. So 1.836 hours. So we now have the information on time required each week from each of the work centers to process 1 unit of X and 1 unit of Y. Now let's find out the time or capacity required on the MPS quantities given to us. So first we will consider product X. Now on the right hand side, I have put the hours required on each of the work centers in each of these weeks to have 1 unit of X produced in week 5. So now let us multiply each of these numbers with the quantity 15. So what this will become is 15 multiplied by 0.517. So I am taking 15 units of X need to be produced in week number 5. and each unit requires 0.517 hours. So in week 5, we require 15 multiplied by 0.517 hours on work center 100. Now, in order to produce 15 units of X in week 5, we will also require 15 multiplied by 0.72 hours of work center 200 in week 4. That is 1 week prior to week 5. So this becomes 15 multiplied by 0.72. Similarly, for work center 300, it will be 0.32 multiplied by 15. So 15 multiplied by 0.32. Now this is done. So let's now move to this quantity here. So again, this is week 4. So in week 4, product X requires 0.517 hours of work center 100. So this will become 15 multiplied by 0.517. Now 1 week prior to that, because the lead time is 1 week, 1 week prior to that, we will need work center 200 for 0.72 multiplied by 15. So 15 multiplied by 0.72. And for work center 300, it will be 15 multiplied by 0.32. So this is also done. Now let's take this one. So 15 multiplied by 0.517, 15 multiplied by 0.72, and 15 multiplied by 0.32. Now this is done. Let's take this one here. So 10 multiplied by 0.517, 10 multiplied by 0.72, and 10 multiplied by 0.32. Now this is done. Let's now take this one here. So 10 multiplied by 0.517. Now this is week 1, so we will have to consider the remaining as past due. I mean, if we were to plan from 2 weeks in advance, then this will become probably week 1, etc. But in this case, since we are doing week 1 to week 5, there's something which is required before week 1 as well. So this becomes 10 multiplied by 0.72 and 10 multiplied by 0.32. Now let me calculate this and put this data in this table here. So I've put the hours here after calculating, and this is how it looks like. So this is the number of hours required from each work center to produce the MPS quantity given to us from week 1 to week 5. Now let's do the same thing for product Y. So here we are considering product Y, and these are the quantities that are required as per the MPS. Now we'll first consider the quantity required for week number 5, which is 25. Now as per the calculation we had done earlier, we require 1.125 hours to be worked on work center 100 in week 5. So this becomes 25 into 1.125. Now for same 25 quantities, we will also need some time from work center 200 in week number 4. So this becomes 25 into 2.37, and for the same 25 numbers, we'll need some time from work center 300 in week number 3. So this becomes 25 multiplied by 1.836. So this is done. Now let's move to week 4. So this will become 20 multiplied by 1.125, and this will become 20 multiplied by 2.37, and this will become 20 multiplied by 1.836, So this is done. Now let's move to week number 3. So again, same thing, 20 multiplied by 1.125, 20 multiplied by 2.37, and 20 multiplied by 1.836. So this is done. Now let's move to week number 2. So 25 multiplied by 1.125, 25 multiplied by 2.37, and 25 multiplied by 1.836. So this is done. Let's move to week 1. 25 multiplied by 1.125, 25 multiplied by 2.37, and since this is past due, we'll just add here 25 multiplied by 1.836. So now let me calculate and put it in this table here. So these are the numbers, how it looks like after the calculation. So now we have the hours required from each of the work centers for product X and Y both. So all we have to do is simply add these two numbers and we'll get the total hours required for production of both X and Y from weeks 1 to 5 on machines 100, 200 and 300. So let me fill that table. So this is how the numbers look like. So this is the capacity required from the work centers 100, 200 and 300 for weeks 1 to 5 for the total production quantity of X plus Y. Now, as we have seen in the 3 methods to perform rough cut capacity planning, there are no rules for determining which rough cut method should be used for an organization or type of operation. However, the decision should be made based on the level of detail needed and the amount of information that is available. The overall factors method provides less accurate output, but at the same time needs very little information, while the resource profile method requires a lot of information and gives better accuracy.